So I hope that most of you watched the video about creating histograms, dot plots, and box plots just to refresh your memory. But what we're going to talk about here today in this lesson is a little bit more about frequency charts. Because dot plots and histograms, we can have the list of data and we can create them and they look all nice and we can color them in, make them pretty. But what do they mean? What are they for? That's what we want to know. And so here we have an example of a bar graph, and it doesn't look like a bar graph because the bars are really, really skinny. They're very tiny. But what this is representing is the score on a test. I'm sure it's not one of my tests because my students do much better than this, but these students didn't do so well. And over here we have the frequency, how often they achieved certain scores on the test. And that's what we mean by a frequency chart. Frequency means how often something happens. Frequency means how often something happens. So, for example, on this frequency bar chart here, we can tell that kids made, a maximum of about 70 on the test. Of course, a minimum of 0. Hopefully nobody actually made a 0. So the range of scores here would be 70. That's one thing we can tell from this histogram. And then we can tell that nobody made 100, right? There's nobody over here. Nobody made 100. We can also probably say that this test was difficult because if we look at the largest number of students up here, almost 50 students made less than a 40. And that's not too good. We like it to be a little higher than that. So the test was obviously pretty difficult. And what if we wanted to know how many students took the test? Well, can we tell that from a histogram? Well, maybe not exactly because it's ranges of data, but we could estimate it. We could say, okay, here there are a couple of students, add 3 more students, add 4 more students, 5 more students, 6 more students, 7 more students. We could add all the bars together and find out how many students total that we had. Well, we call this a discrete representation because we have the individual bars. But we could also represent this as a continuous representation. And so what this is, see, it looks just like this. So it's the outline of the histogram. And if our ranges are really, really small, it's much easier to make this kind of continuous representation. But we can get the same information from this continuous representation. We're going to talk a little bit more about that. But the activity you're going to do next, you're going to have some frequency graphs, and they're also test scores or quiz scores or homework scores, some kind of scores. And the scores are here at the bottom from 0 to 100. And then over here is the frequency. This is always the frequency over here in these frequency graphs. So you're going to be deciding which one of these descriptions goes with this graph. So in this case, the first description says this was the sort of test where you could either do everything or you couldn't get started. You could either do everything or you couldn't get started. In other words, you did really well or you did really badly. The other description says in this test the median score was smaller than the mode score. You already know what median and mode are. Median is the center number. Mode is the average. Add them all together and divide by the number of data points that you have. Well, if we look at this graph over here, we see that nobody made a 50, but a whole bunch of people made a 0. 30 students made a 0. Also, though, 30 students made 100. Well, our median and our mode are both around here because even though this is concave or goes down, it's still symmetrical. It's the same over here as it is over here. So our median and our mode are pretty much the same. So this one really doesn't describe this data, but this other one does. Everybody did really well. They either made 100 or 90 or they did really badly. They were down here at 30 or maybe just they were down here at 0 or maybe even just a 10. So you would match this graph with this description. All right, we'll go on to the next screen and see how you do.